Hi students, this is lesson 51 actually. This was supposed to be Tuesday's lesson, but since I'm not here today, we're going to do this as lesson 51 or day 51. Okay, so today we're going to be talking about solving absolute value equations and inequalities, and here's our objective. So if we could have the teacher please pause the video here and have students write this down. Alright, so absolute value is something you should know already. The absolute value signs look like two bars. You might have like absolute value of -4, meaning like how far is -4 from 0? Well, it's 4, right? Or the absolute value of +4 is how far is 4 from the number 0? It's still 4, right? So there's two ways to be 4 numbers away from 0. Okay, so here's another way I like looking at it is, let's say, I'll jump to the next screen. Let's say you had your house, right? And let's say you walked 4 blocks away to +4. How far away are you from your house? Well, you're still 4 numbers away, so the absolute value from your house is 4. Well, what if you are like -4 blocks away? How far are you from your house? Are you -4 blocks away from your house? No, you're positive because you don't go negative distance, so your absolute value is still 4. So when we talk about like this absolute value of x is equal to 4, it's saying how many ways can I be a distance from 4? Well, how many ways can you be a distance from 4 from your house? Well, 2, right? You could be -4 blocks away or +4 blocks away. So when we do this in math, look at this up here. When I solve this, when the absolute value is isolated, you would take two equations. You're saying, well, absolute value of x is equal to 4. There's two ways I could be the distance from 4. I could be x is equal to 4 or +4, right? So I would say this is a positive distance, and then I could also be a negative distance. Right, and I could solve to get x by itself, so x is equal to -4. And see, these are the two answers that I started with. So that's the concept. So how many ways can I be from 0 to? So in these problems, you'll have two answers, okay? So that's what absolute value means. It's the distance a number is from 0. Alright? So let's go back to the steps. Let's have the teacher pause the video here and write down the steps, please. Let's have the students write down the steps. Alright, so students, you should have written down the steps. Here we go. I'm going to show you a couple problems. One's going to be a regular equation. You see there's an equal sign right here. And then the second one's going to be an inequality right here. So I'll start with the number 1, okay? Eyes up on the screen, pencils down. Here we go. So the first thing I want to do, it says solve and graph. So I want to get the absolute value isolated on one side of the equation. There's the equal sign right here. There's absolute value here and here, so I want to isolate it. It already is, so that's nice. So since the absolute value sign is isolated, I can move forward and I can make two equations. So I'm going to take each of these, or take the original equation and rewrite it and make the absolute value, change it to a parenthesis and make it positive, and then take the other, take one more equation and make it negative. Okay? So I have a positive and a negative equation here. Alright? So first thing I do is work out this first equation on the left. I could subtract 2 on both sides. So I'm going to subtract 2 on both sides. I get 3b is equal to 5. And then I could divide both sides by 3. So b is equal to 5/3. Okay, that's the first answer, so I could box that. Second equation, I have this negative sign in the front here. You see this negative sign? I could say that that's like -1 times this quantity of 3b plus 2. So I'm going to divide both sides by -1. So the negative 1's cancel out, just leaving 3b plus 2. Okay, and then 7 divided by -1 is -7. Okay, so I'm going to work out the problem just like I did last time, subtracting 2 on both sides. So 3b is going to be stay on the left side, and we got is equal to negative 9. Divide both sides by 3, and then I get b is equal to negative 3. Box my answer. So I have two answers here. I could leave my answer like this. Another way you could write it is the following. You could just say, you could use these parentheses with a little point at the end of them. And I'm just going to take the smaller answer, negative 3, and then 5/3. I'm saying this is the set of numbers that are there. It's kind of like my range, or domain, we could say. Okay, so, excuse me. What we're going to do now is write down my answers or graph them. So I'm going to go to negative 3 and fill it in. I'm saying that's one of my answers, and 5/3. And that's my answer, which is like saying, that these are my two answers in this equation, because the original problem had an equal sign there. If you see the original problem, there's an equal sign. So there's only specific answers. Okay, so that's number 1. Number 2, I noticed that the absolute value sign is not isolated, and I also notice there's a 4 here being added, so I want to move this 4 over here, doing the opposite, which means I'm probably going to subtract by 4. And then the other thing I noticed, look at this, it's an inequality. So it's going to be a different kind of answer. I'm just going to have a range of answers, not a specific answer like number 1. Okay, so same idea. We're going to isolate the absolute value, so I'm going to subtract 4 on both sides. And when I do that, I'm going to get the absolute value of 6y minus 2 on one side is less than 18. Now my absolute value sign is isolated on one side of the equation, so I'm going to create two equations here. One is going to be positive 6y minus 2 is less than 18. The other one's going to be negative 6y minus 2 is less than 18. Okay, working on this left one first. Here we go. So I notice it's positive, which is nice. I could just start solving, and I'm going to add 2 to both sides. So 6y is less than 20. Divide both sides by 6y. I'm divided by 6, and I get y is less than, I could simplify this, 10 over 3. Okay? That's my first answer here on number 2. The second answer, I have a negative sign here. Remember, this negative sign here is like saying negative 1. So what's the opposite of negative 1? Multiply by negative 1? Divide by negative 1. So be careful here now. Here's a trick that I taught you before, and I know that you should have been taught this before in Algebra 1 and Geometry and before that. So when I divide by negative 1 or any negative number, or multiply by negative, I have to take my less than sign and bring it down to make it a greater than sign. Okay? So hopefully you remember that. And of course, 18 divided by negative 1 is negative 18. Now I'm going to add 2 to both sides. When I do that, I get 6y is greater than negative 16, right? Divide both sides by 6. I get y is greater than negative 8/3, right? Because 2 goes in each of those. So I'm getting a different answer here. So I'm getting a range. So now I'm going to graph this. I'm going to do 10/3 now, which is like saying 3 and 1/3. I'm going to go there. It doesn't have the little equal sign in my answer, so I'm just going to leave it empty. And I know it says less than, so it's going to go to the left. My answer range is going to go to the left here, right? So I'm going to leave that, just put a pencil mark there, or a mark there that I know it's going to the left. And then the second answer is saying y is greater than negative 8/3, which is saying y is greater than negative 2 2/3. So I'm going to put a circle mark there. It's going to the right. And I notice these two lines are going together, so there's my answer. Okay? So we're doing equations and inequalities today, solving them. Same process. Some of these things you should know already from solving from Algebra 1. So yeah, let's have the teacher pause the video here, and let's have students write down numbers 1 and 2 in their notes. Okay, moving on here. So numbers, let's go to number 3. Students, let's just have you do this in your notebooks. You'll check your own work. So number 3, please write that down. And here we go. First thing I'd like you to do, kids, let's do this one together. Just the first part. So we see that the absolute value is isolated here on the left-hand side. So since it is, I can make two equations. So let's write this down. X minus 2 is equal to 4, and that's positive x minus 2. And then we're going to do negative x minus 2. And then, of course, we're solving this. So we're going to add 2 to both sides. Let's have you solve this. Let's have the teacher pause the video here, and let's have students work this out for about 30 seconds. Alright kids, you should have finished this problem off. So I would add a 2 to both sides here, making x is greater than or equal to 6. Second one, I'm going to divide both sides by negative 1, so x minus 2 is equal to negative 4. Add 2 to both sides, x is equal to negative 2. And then, I could write my answer like that, plot my points. Okay? Let's do number 4 now. Students, please write this down. Okay, so number 4 is a little bit more complicated. You have a problem here that has an absolute value that is not isolated. You have a 3 right here that's being multiplied with it, and you have 5 being subtracted from it. So I'll help you out at the beginning, then you're going to finish up the problem. First thing I would do is add 5 to both sides here to isolate it. So we got 3 times 4yw minus 1 is equal to 15. And then I would divide both sides by 3. So I get 4w minus 1 is equal to 5. And I would make two equations because it's isolated. So I'm going to let you finish up this problem here. Let's have the teacher pause the video so the students can finish up the problem. Alright, students should have worked this problem out, and this is what you should have had. You should have written one problem that was positive, so it would be positive 4w minus 1 is equal to 5. The second one's going to be negative 4w minus 1 is equal to 5. Add 1 to both sides here. 4w is equal to 6. Divide by both sides by 4, so you get w is equal to 3 halves. Second one, we're going to divide both sides by negative 1, so we get 4w minus 1 is equal to negative 5. Add 1 to both sides. 4w is equal to negative 4. Divide both sides by 4, and we get w is equal to negative 1. And plot my points. Okay? You might want to pause the video here for students to write anything down before we go to the next one. Alright, so next one, number 5. We got 2 more to go. So, number 5, let's have you write this down. Let's take a moment to write this down. Okay, so this one's like number 4. But it's a little different. You see how there's that less than or equal to sign here, which means we have an inequality. So we have to be careful. We have to look at like our problem from number 2, the number 2 example. So here we go. So we should be adding 9 to both sides here first. I'll start you off and you'll finish up the problem. Okay, so you got 3 times 2x plus 6, the absolute value of that. And then we're going to divide both sides by 3, and we get this absolute value sign that's isolated. Look at number 2 now, and I'd like you to finish up number 5 for me based upon that. Okay, so let's have the teacher pause the video here, please. Alright students, so you should have worked this out, okay? So you got 2 answers, so you should have positive absolute value of 2x plus 6, right? And they got negative absolute value of 2x plus 6. And so this first one we're going to subtract 6 on both sides. You got 2x is less than or equal to 2, so x is less than or equal to 1, right? Next one, you see how you have that negative 1 there? Divide both sides by negative 1. What do I do with this less than or equal to? Change it to a greater than or equal to, right? Remember that? Yes, so 2x plus 6 is greater than or equal to negative 8. Subtract 6 on both sides, dividing both sides by 2. We get x is greater than negative 7. I'm going to plot my points, and I'm filling them in. You'll notice that because they include those as answers, okay? Whew, that's fun, right? You're doing a good job. Let's do this last one, okay? I want you to do this one all by yourself. You might get stuck. And be careful. This one's a little bit conceptual, so let's have you work this one out. Let's have the teacher pause the video here and have students work this out. Alright kids, so here we go. watch carefully. So, of course, I know you would have divided both sides by -2, of course, right? And, of course, our less than or equal to sign, less than sign has to change because we divided by negative, right? Divided by -2. So, I'm changing this to a greater than. So, I got absolute value of x plus 4 is greater than -11. So, let's think about this. What does an absolute value sign do to any number? Let's say an absolute value, remember, of -4. Just remember this. What's the absolute value of a -4? Well, it's +4, right? And the absolute value of +4 is going to be +4, right? So if the answer is always a +4, what's wrong with what we see here? Well, look, we're saying an absolute value of x plus 4 is equal to a negative. Does that even work? Does an absolute value sign ever make something negative? No, it doesn't. Which means that there's no number that I could put in for x that would cause it to make this equation true. So then our answer is going to be no solution. Yep. That's a little bit frustrating, I know. But that is the answer to that one. So think about that as you work these out. Let's have the teacher pause the video here and have students write these examples down. Okay, and then students, let's have you discuss. I know I'm not here to follow up with you on the closure, but it's still important. Students, let's have the teacher pause the video here. Let's have the students discuss this for about a minute. What do we learn? How do we do that? Let's just go around. Let's have ones talk about this, twos talk about this, threes talk about number 3, and then fours talk about number 4. These are a little bit different than normal, right? Numbers 1 and 2 are pretty much the same, but what helps you understand absolute value? Let's have threes talk about that. And then fours we'll talk about. In an inequality, when does an absolute value not make sense? Think about number 6, okay? So let's have the teacher pause the video here for about a minute, have students discuss this. Alright, so let's have you do a little practice in your groups. Kids could do this in their notebooks. Teacher will pause the video here, have students write or work these out in their groups. Give them until about 10 minutes to work these out. If there's not enough time, give them until like 2 minutes to the end of the period. And let's show these answers. Okay, so let's pause the video here and kids will work in their groups working these out. Alright, kids should have worked these out, so you should hear the answers. Check these out. Now you'll notice like number 5, this is like number 6, there's no solution, but look at number 8. You know, you work out number 8, this is also conceptual, right? When is an absolute value going to be greater than a negative number? Well, doesn't an absolute value always make things positive, right? So is it always an absolute value going to be greater than a negative number, right? Because it's always going to be positive. So this last one's going to be all real numbers. I know it's a bit confusing, but you know, think about these two concepts, okay? Alright, that concludes the lesson. Happy Halloween. Hope you kids stay safe and be good. There is no extra homework, no extra AMs tonight because I know you won't do your homework. You're going to be just doing your stuff. So, but we'll start catching up tomorrow for the rest of the week. So, alright, thank you kids. Have a good day. Bye.